In this video, Hanim and Nashwa will going to discuss about crystal structure of fluorite.
Hanim, what is fluorite?
Fluorite, also known as calcium fluoride. It has a chemical formula CaF2. It consists of calcium and fluorine ions. Fluorite has a hardness of 4 on the Mohs scale, making it relatively soft compared to mineral. Next, one of the most captivating features of fluorite is its wide range of colors. Colors can include purple, blue, green, yellow, and even clear or transparent crystals. The variety in color is often due to the presence of trace elements during its formation. Lastly, fluorite has a relatively high density, ranging from 3.0 to 3.3 gram per centimeter cube, depending on impurities. The density contributes to the weight and feel of fluorite specimen. Now, let's take a look at the structural model of fluorite that we have built. There are two types of arrangement, which are unit cell and lattice. Unit cell is the smallest repeating unit, which shows the full symmetry of the crystal structure. For fluorite, the unit cell is face-centered cubic. In the case of fluorite, calcium atoms with fluorine occupying the 8 tetrahedral intersection sites. Each calcium is coordinated to 8 fluoride anions F-, which in turn is surrounded by 4 Ca2+ cations. Lattice is an infinite array of points in space in which each point has identical surroundings to all others. The lattice is also face-centered cubic. It means that the repeating unit of the crystal structure is a cube, and atoms are located at the corners and the centers of the faces of each cube. The lattice provides a framework for understanding the long-range order and symmetry in a crystal.
Next is the unit formula Z. Unit formula is the number of atoms or ions contained in a single unit. As you can see here, this is the figure of fluorite structure in the FCC lattice, which is face-centered cubic. When we look at the structure, the red dots represent the calcium 2+ ions, while the blue dots represent the fluoride ions. Firstly, for the number of calcium 2+ that contained in a unit cell is 4. How can we get 4? Calcium 2+ is occupied at corners and centers for each face of lattice. So there are 8 corners times 1/8 plus 6 faces times 1/2. So the unit formula Z for calcium 2+ is 4. For the fluoride ion, it located at each center where 8 centers times 1, so it's equal to 8. So the unit formula Z of fluoride structure is 4. Let's go detail about the location of each atoms. For the first picture is from the top view. As you can see here, calcium ions are located at the corners of the unit cell and at the center of each face of the FCC lattice. There are a total of 6 face-centered positions in an FCC unit cell. Let's look at the second picture. The fluoride structure can be regarded as Ca2+ cation form a cubic close-packed structure, while the F- anions occupy all the tetrahedral holes. The green dots at the second picture is represented as the fluoride ion, while the grey dots is represented as the calcium ion. Fluoride ions occupy the tetrahedral sites formed by connecting the mid points of the edges of the cube defined by Ca2 plus ions. Each fluoride ion is positioned at a tetrahedral site within the lattice. These tetrahedral sites are shared among neighboring unit cells. In the fluoride crystal structure, calcium ion occupy the face-centered position while fluoride ions occupy the tetrahedral site. For the coordination number of Ca2+, each calcium ion is surrounded by 8 fluoride ions. These 8 fluoride ions are located at the vertices of a cube that shares a face with the central calcium ion. Therefore, the coordination number of Ca2+ is 8, while the coordination number of F-, each fluoride ion is in contact with 4 calcium ions Ca2+. These calcium ions are located at the corners of a regular tetrahedron surrounding the fluoride ion. Therefore, the coordination number of F- in the fluoride crystal structure is 4.
Last but not least, we're going to discuss the application of fluoride. First, fluoride is used as a plug in the ceramics and glass industry to reduce the melting temperature of raw materials, enhance the transparency of glass, and improve the properties of ceramic products. Secondly, fluoride are used in the manufacture of lens and optical components for cameras, microscopes, and other optical devices. Fluoride's low dispersion and excellent light transmission properties make it valuable in optical applications. Fluoride is also used as a plug in metallurgical processes, especially in the production of aluminum and steel. As a plug, it lowers the melting point of raw materials and facilitates the removal of impurities, improving the efficiency of metal extraction. Fluoride's fluorescence under ultraviolet light makes it useful in the production of fluorescent lights and lamps.